All right. Okay, and away we go. This is our first video where we're actually going to solve one of these by graphing, okay? So we've got a couple things we need to remember here, right? And that's our axis of symmetry and finding our vertex, plotting points, all of that, because basically the very first thing we have to do is we just have to graph this. Don't worry about the solve part until you actually graph it, knowing that we're going to get a parabola. So before we graph it, let's just look at a couple quick features of this. Well, the first thing is your A and your B terms, and we're going to need those for our vertex, right? Because so that's going to be your A, this is going to be your B term, and then this is your C term, but we don't really need that for our purposes yet. All right, so my A is going to be 1 because there's not a coefficient there, and my B is positive 6, right? So I know those two things. All right, I also know because A is positive, right? A is greater than 0, so if that's the case, this thing is going to open upward. All right, this thing's going to open up, so it's going to look something like that going up, right? Maybe not quite that crooked, but you never know when I'm graphing. All right, now that's about all I can tell you right now with what we know, with the knowledge we've gathered so far about this. That's what we know. We know this thing's opening up. I know what A and B are, and I know that my next step is to find my axis of symmetry. I want to see how is this parabola split, right? What's the line of symmetry that I'm going to use? So it's negative b over 2a. So I always try to think of when I see a negative in an equation, I always think of it as the opposite. So it's the opposite of whatever b is. So if b is positive, it becomes negative. If b is negative, it becomes positive. And if you think about it that way, like when you do hit a double negative, it's not quite so complicated. But in this case, it's positive, so not an issue. So you just put that in there like that. And then we have 2 times a, and my a is 1. All right, so I have negative 6 over 2, which gives me negative 3. So that's my x-coordinate on my vertex, right? So if I say my vertex over here, and then I go like this, and I'm going to put negative 3 in a comma, and we are going to wait with great anticipation to fill in that y-coordinate. Well, rather than wait, let's just find it. So we're going to take this negative 3, and we're going to put it in this equation, because that's how an ordered pair works, right? Is they should zero out and be a solution to the equation. So let's do this. We're going to go negative 3 squared plus 6 times negative 3 plus 8. Okay, and let's solve, man. Negative 3 times negative 3 is positive 9, because remember, this is what you're doing when you raise something to the second power. You're taking whatever it is and you're multiplying it by itself. You're not going negative 3 times 2. That is not what we are doing here, right? They would write it like that if they wanted that. So the exponent means that that's repeated multiplication, negative 3 times negative 3. All right, 6 times negative 3, well, 6 times 3 is 18, and then a positive times a negative gives you a negative. So we have 9 minus 18, and then we have plus 8. All right, so if you don't like going left or right, you can just kind of break these up so that they're kind of like islands unto themselves, and then combine your positives and your negatives, and then do one last final weird computation. So we've got a positive 9 here and a positive 8. That's 17. So we have 17 minus 18, and then that gives me negative 1. So my y-coordinate now is negative 1. So my vertex is, I'm going to go over to negative 3. All right, and I'm going to go down to negative 1. We're going to put a point. And there we go. Right, next. When we graph parabolas, right, we always try to find 2 points. The strategy that I try to teach, that I think that makes sense to me, and so I teach it, is I pick the next 2 integer values to the right of the vertex usually. All right, and the reason I do that is because they're easy numbers, and I also know that they're going to fit on the graph, because the next 2 numbers should be well within the start of the curve. If you start picking something further out, it's going to be like, way up in the stratosphere and off the screen, right? Not going to fit on our graph. So in my middle here, I should have my equation, and I'm just going to substitute in the next 2 integer values to the right. So that's going to be negative 2 and negative 1. So I've got negative 2, I've got negative 1, and then just rewrite the equations, substituting a pair of parentheses in the number wherever you see your variable. So negative 2 squared plus 6 times negative 2 plus 8 If I simplify that, you're going to get 4 minus 12 plus 8. Right? Well, 4 and 8 make 12, and 12 minus 12 is good old 0. So we have negative 2, 0. And because, if you remember, right, and hopefully you do, if you remember that my vertex is basically my line of symmetry, right? So I'm going to reflect this point over on the other side of this. So it's a mirror image, right? That's what reflections are. Okay, so now I got 3 points. Let's put that negative 1 in, and let's see what happens here. So we got negative 1 squared plus 6 times negative 1 plus 8. Well, you get 1 minus 6 plus 8. Well, 1 and 8 make 9, right? And 9 minus 6 is 3. So I get negative 1, 3. So negative 1's right here, 3 is up here, and then we will reflect it. So you go, okay, we've got 2 units here, right? So that means we're going to have 2 units here, right? And that's a really solid way to think about this that I think will help you not get into too much trouble. All right, so let's erase that because we don't really need it. Okay, and then we will plot our points. So let's replot our points, right? So we have negative 1, 3, and then we're going to be over here. Okay, plot my reflection. You don't even really need to know the points of it. It's just a matter of, can you graph this thing? Right? What just happened there? That was crazy. Right? Let's select that and make that go away. Uh-oh, not like that though. All right, so this is, all right, not working is what it is. So we're going to just take you and move you. All right, so I'm not happy with that. All right, there you go. All right, so let's redraw our parabola here. So we go up, right? And go up here. Oh, wow. That got kind of nuts. Okay, now the main thing we're focusing on here, though, is not necessarily how crooked Mr. Simons draws his parabolas, and we've established that in the past video that I'm not good at it, right? At least not with this thing. But what we're looking for is we are looking for where does this thing cross the x-axis, because that's what we're looking for. So that's these points right here. And if you look at your thing here, right, it's negative 2. That's where one of my zeros was. And then when you reflect negative 2, that's when you get the other one, and you realize it's going to be negative 4, right, because it's one away from the vertex. It's symmetrical, so it has to be the same distance away. So my solutions are going to be x is equal to negative 4 and negative 2. Usually when I write these, I go least to greatest. I just think it's, I think it looks neater. Some textbooks do it the opposite, right? Doesn't matter. Do it however you want. But that's kind of the basic idea here, right? So we're just graphing this thing, and then where we're taking it further now is we are recognizing and interpreting the fact that because this parabola crosses the x-axis in certain spots, those are the solutions, and that's what we're looking for. And so this is a case where we have 2 solutions, right? You have 2 roots to this, right? So you have 2 real roots. And we're saying real because later on we'll start dealing with some numbers that really are that we call imaginary numbers or complex numbers, right? But we're not dealing with that yet. So we got 2 real roots. They are negative 4 and negative 2. All right, I'm going to stop the vid, and I will catch you in the next one.